Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today we will cover chapter 6, trusses. Right. So in chapter 6 we have trusses, frame and machines. So for today we'll focus on trusses. Right. So basically these are all different type of structures that we can see in the real world. Right. So but the way we analyze and the way we compute the forces is different between trusses and frame and machine, and we have covered that in the lecture, right? So there's a fundamental difference why trusses can be analyzed differently, right? Because every member is a two-force member, hence we can just focus at the joint, for example, because we know exactly where is the direction of the force. But for frame and machine, it will be different, right? Because the member is normally not two-force member, it's multiple force member, right? Hence we have to consider the moment, etc. Right? But anyway, before going forward with this tutorial, just to give appreciation of why we even learn about trusses. So I think you have seen some structures like this, right? For example, if you see the roof structure before it is completed, you can see trusses in many places being applied, right? So with that, meaning that it is something real in our real structures, it is being used widely, and hence it is important to know how to analyze this, especially if you are going to be working in that field. Anyway, so with that said, we will focus on past exam questions on trusses, and the questions are in the description box below. You can download the PDF and see the questions. Whichever question that you feel you want to cover, you can jump straight to that question, right? So you can see the timeline have each questions where we cover that portion, right? But just to give you a context, in the sense that this is all, my tutorial is all covering what is the past year or past exam questions, right? So in the context of trusses question in the past exams, normally because of the allocation of marks for each question to distribute quite evenly or something, the question for trusses tend to be the shorter ones, and you can see after this the type of questions from the past exams tend to be the shorter ones, right? So just because it is so in the past, it means that it will be so as well in the future, right? So there's no guarantee as such, right? So the question can be a longer question in your exam, depending on the semester what happened, or depending on your university if you are not from my university, right? So that's just to put in context so that you do not think that this is the only type of question that can come up for trusses in the exam, right? So just to put in context, right? So you will see the question is on the shorter side of the questions, right? So without further ado, I think we'll just go straight into question number 1. Okay, this is question number 1. So you have the structure there, you have the forces, and then the dimension is given. So the question says, by using method of joints, determine the force in member AF, BF and BC of the truss shown in the figure. State whether the members are in tension or compression. Clearly indicate which equation of equilibrium is based on which free body diagrams. Alright, so the question state specific members that we have to solve, meaning that we do not need to solve for all members in that case, right? So and then it says that you have to also state whether it's tension or compression, that's normal, and then you have to clearly say which equation is which free body diagram, right? So because sometimes we have to use multiple free body diagrams, and for each free body diagram you have its own equation of equilibrium, right? But sometimes in the exam some students do it quite, it's hard to follow which equation belong to which free body diagram, right? So that's where the question state as such, so that if you do not comply, you might lose some marks there. All right, so if from the diagram, in this case, okay, in this question it did mention, right, truss. So you know, it's truss, right? But you have to be able to identify, even if the question just say find the force in what member, you have to know this is truss or this is frame or machine, right? So because the way you will analyze afterwards, is different, right? So I think you have understood what is a truss from the lecture. We'll go straight forward in terms of solving, right? So looking at the structure there, we need to find for member AF, which is the bottom left there, member BF, okay, the diagonal bottom there, and then member BC, the bottom right there, right? So we need to solve the answer. In the final answer that we have to give is the bottom three, right? Three of the bottom members there, right? So actually there's two ways to get to that member, right? So one is you solve from the top until you reach the member that you need to calculate, right? Or you solve the support reaction at the bottom and then you go bottom up, right? So either way, it should give you the same answer, right? So we will first solve from top to bottom, right? So that's normally what people would do, I think. So when you look at any trusses that you want to solve, the first question before you draw any free body diagram is there any zero force member, right? So you have to be able to identify just by observing, is there any two force member, right? So in the lecture we have covered how to obtain or how to observe which is the two force member, if any, right? So basically there's two rules, right? So in this case you can see that, so if we put the first step, okay, first in terms of the purpose of the exam, always this is a suggestion, always write what is the final answer that you have to provide, right? So that you do not forget along the way, right? So you have to find FAF, and then FBF, and then FBC, right? That's the three forces that you have to give in the end, right? So put it there at the top of your paper so that whenever you calculate, you can just refer what I need to calculate again, so you can just refer back. All right, so first identify zero force members, if any, right? So in some question there are zero force members, some question there are none, right? So in this case, you should be able to identify that there are two zero force member, right? So if you look at point D, you can see that, okay, that means that ED and DC is zero force member, right? So you have member DE and member CD is zero force member, right? So basically FDE equal to 0 and FCD equal to 0, right? So that's zero force member, okay? It's fine. Of course, if the question asks for every member, then you have already get the two answers, right? But in this question, it doesn't ask for that. It just asks for three specific members. We haven't reached it yet, right? Now, having done that, then we can draw the free body diagram at point E, right? So to solve the two member down there, right? So at that point, so we have 6 kilonewton there. Of course, because DE is 0 already, we already have zero force member, then there's no force there, right? And then if I assume all the force to be in tension when I do not know, so this will be FEF, and then this will be FCE, and then the angle. So if you look, it's basically 1.52, right? So that ratio 1.52 is basically 3, 4, 5 triangle, right? Hopefully you can identify this angle, right? So either just looking at 1.52 is basically 3, 4, 5 ratio, or you can also put 1.5 to 2.5, fine, right? Because the ratio is the same. Okay, from here you should be able to solve these two, right? So we can solve summation of fx first. So summation of fx equal to 0. So this will be 6, and then plus FCE, and then you have 3/5 equal to 0. So FCE, it will be a negative value here. 6 times 530 but divided by 3 is 10, right? 10. This is kilonewton or newton? Kilonewton, right? Kilonewton, meaning that this is compression, right? Alright, so you have solved for FCE, meaning that it's actually compression. So when you do summation of Fy equal to 0, so we'll have minus FEF, and if I'm still referring to this free body diagram, it's downward, right? So minus, but the value of FCE we know is negative 10 based on this diagram, right? Negative 10, because it's actually the opposite direction. And then you have 4 over 5, and then equal to 0. So based on this, you have FEF equal to 40 divided by 5 is 8 kilonewton, right? This is in tension, because it will be positive there, right? So negative bring there, so it becomes positive. So we know these two value already, right? So looking back at the diagram there, we have now already FEF and FCE. Now we can solve for the bottom part, right? So we can start, we can follow it with point C, right? So free body diagram at point C. Can you do to point F straight away? You can't, right? Because you cannot solve straight away, because you have 3 unknown now connected to point F, right? So that's why we find where is the point where we have only 2 unknown. So here we have at point C you have 2 unknown, right? So at point C, if I draw the unknown first, these two, right? So this is FCF, and then this is FBC, right? That's the unknown. The known one, okay, FCD. FCD is 0, okay? So FCD is there's none. FCE, we have known this one. It is compression. It's 10 compression, right? So it should go like this. It is 10 kilonewton. This is compression, right? So the ratio is 3, 4, 5. Okay, so hopefully you understand how we get from here to here and why is this direction like this, right? Because we know it is compression. So when you draw a free body diagram, compression, it goes into the point, right? So all right, so based on this, you can solve for the 2 unknown, right? So for example, summation of Fx equal to 0. So you have minus FCF, because it assumes tension, plus then 10 3 over 5 equal to 0, right? So FCF, you'll get 30 divided by 5, 6 kilonewton. This is in tension, right? Because it is positive and we assume originally is tension, right? So then this is already one of the answer, right? No, not yet. FCF, no, not yet. But this one is, right, FBC. So when you do summation of Fy equal to 0, then you'll have minus FBC minus 10 4 over 5 equal to 0. So you'll get FBC, a negative answer there. So we get 40 divided by 5, 8 kilonewton. Meaning this is compression, right? So meaning it is actually 8 kilonewton compression, because the direction is upwards, right? So FBC is one of the answer that we need. So that's one answer, right? So next we can go to point F, free body diagram at point F. Do we have enough space here? Okay, never mind. So because we can just push away the diagram when we don't need it anymore, right? So if you draw the free body diagram here, okay, so you have 9 kilonewton here, and then we have the 2 unknown that we want to find here, FEF, FBF, right? And then FCF here, we have known it to be tension 6, so it goes like this because it is tension. And for FEF, we know it's also tension, so going up 8 kilonewton, right? So hopefully by now, I'm assuming everyone have gone through the lecture and you understand how we denote compression and tension in our free body diagram, right? So do check out the lecture video first if you haven't covered it yet and you cannot understand some of the things. All right, so so 3, 4, 5. Alright, so based on this, you can solve for this too, right? So let's do summation of fx first equal to 0. Okay, it's going into the light already. Okay, anyway, so we'll have, okay, 9 plus 6 plus fbf 3 over 5 equal to 0. Right, so based on this, fbf, it'll be negative value, right? So 9 plus 6 is 15, 15, and then divide by 3 is 25, is it? Minus 25 kilonewton. If this is correct, this is compression, right? So I have to check, is it? Yeah. So minus 25 kilonewton, which is compression because of negative, right? Okay, so you have solved for FBF, right? So you can solve for FAF using summation of Fy equal to 0, right? So based on this, you have 8 upwards and then minus FAF, and based on this, it's still minus based on the free body diagram, but because the value based on the free body diagram is negative 25, so you have negative 25 here times 4 over 5 equal to 0. Alright, so based on this, what will happen here? 25, 120, right? So 20 plus 8 is 28, right? So FAF becomes 28 kilonewton, right? It will be, this is positive, so okay, so positive, so meaning it is tension, right? So you'll get 28 kilonewton tension. So you have solved for FAF, FBF, and FBC here, right? So this is solved by using from top to bottom. If you take a look at the original diagram back, we actually solve from top to bottom, and then we solve for these three, right? So if any of you want to solve from the bottom, is it possible? It is actually, right? So it's up to you which flow of calculation is easier for you, right? So we will just demonstrate how that will become, right? So we'll erase this first and we'll show an alternative solution, right? It's up to you which one you prefer, but I'm just showing so that you understand there are multiple ways. Right, so we are at the starting point back again. We have the question and we need to find the three unknown, right? So what if we try to find the support reaction first and then go from bottom up, right? So can we do that? Yes, we can, right? So to do that, of course, we have to do properly. So we have to solve support reaction by using in the previous chapter that you have learned, right? So we have learned how to solve for support reaction, right? So for this case, so we have the structure something like this, right? And then basically something like this, right? That's the whole structure. So we have 6 kilonewton here and then 9 kilonewton here, right? And then we have the support. So at A you have AX and AY because it is a pin support, and at B you have normal reaction, so we'll label it NB, right? And hence, okay, the other dimension 2 meter and 1.5 meter, right? So that's the free body diagram of the whole structure to solve for these three unknown of the support reaction, right? So based on that, if I take summation of moment about point A equal to 0, so let's take counterclockwise positive, for example. So I take moment about here, so I can solve for this one, right? So in this case, NB time a distance of 1.5, it is counterclockwise, so positive based on my notation there. This one doesn't produce any moment. This one will produce clockwise, so minus, so you have 6 times 4, and then minus 9 times 2. This all should equal to 0, right? So based on this calculation, you can calculate for NB, which is, after this calculation, you will get 28 kilonewton. Of course, it will be upwards. If you get something negative here, something is wrong, because normal reaction can go only in that direction, right? It's not assumption. This is confirmed upwards. Based on that value, so you can do summation of fx equal to 0 if you take on positive to the right. So you have 6 plus 9 plus ax equal to 0. So basically ax is negative 15, is it? So meaning it is to the left actually. Right, so this ax we assume wrong. Not a problem. I'm not saying when we assume wrong there's something to panic about. It's just that, oh okay, it means it is to the left. Right. So when you do summation of fy equal to 0, upwards positive for example, so you'll have ay here and also nb, so plus 28. So ay becomes negative 28 then, meaning it is downward. Right, so we have known these three unknown. Now it's no longer unknown, it's known. So we can go from bottom then, right? So for example, what? For example, if we go for free body diagram at point A, because we already know ax and ay, so we can draw the free body diagram there, right? So now ax is left, right? So we have left 15 kilonewton there. Ay is downwards, 28 kilonewton there, right? So we know that already. So what we want to find is FAB and FAF, right? From this free body diagram. So this one straight away you can do summation of fx and fy, right? So for example, summation of fx equal to 0, then you have FAB minus 15 equal to 0. FAB equal to 15 kilonewton, it means tension, right? Now a note here, right? So this is depend on the lecturer or examiner, right? So but for me, I really want to see all the fundamental steps, right? So even though it is as obvious as this, looking at this, obviously FAB equal to 15. But for me, you still have to write the equation of equilibrium, right? So summation of fx equal to 0. I want to see what is the summation of fx equal to 0 before you calculate, right? So you have to express all of this equation of equilibrium first, right? Okay, so you get that one, and then summation of fy equal to 0. You have FAF minus 28 equal to 0. So FAF, equal to 28 kilonewton. This means tension, and that's one of the answer, right? FAF. All right, so that's one of the answer that we need. Okay, so we are running out of space, but anyway, we'll just follow. So after you have solved this one, you can go to point B, right? Because right now point B you already have FAB known, so you are only left with two unknown, right? So free body diagram at point B. So if you draw that, so you have the normal reaction NB here, which is 28 kilonewton, and then you already know FAB, which is tension. So tension going out 15 kilonewton, and then you have FBC and FBF. So this ratio is 3:4:5 ratio, right? Just like before. Alright, so having known this one, you can solve summation of fx equal to 0. So here you have minus 15 minus FBF 3/5 equal to 0, right? Only two components that have x. Okay, so based on that, FBF equal to 25, right? Divide by 3 is 5 times 5, 25. So negative 25 kilonewton means compression, right? So that's one of the answer, FBF, and it is negative 25, correct? Yeah. So the same as before the answer, right? So when you do calculation for summation of Fy equal to 0, then you have 28. You have, okay, based on this free body diagram is plus, but the value FBF is already known to be negative 25, and then we have, this is for Y component, right? So 4/5, and then you have plus FBF equal to 0. So based on this calculation, so you have, what is this, 25, 100, about 20, right? So 28 minus 20 becomes 8, right? So FBF, then bring other side, negative 8 kilonewton becomes compression. Right, so you have solved all the answer as well, right? So FAF, FBF, and this is FBC. Well, this is FBC. Sorry, why is it FBF? Sorry for that. So this is, hopefully you noticed that mistake just now, right? FBC, FBC. Yeah, is there any other mistake? So FBC, right? So that's where I think what I write in the beginning help, right? So I noticed, wait, I did not just confidently, yes, right? So that's where you note something important up front, so that you can just always check and make sure everything tally, right? So that's, in terms of the exam, that is very crucial. Okay, so we have shown both how to solve from the top, we're using trusses, or from the bottom. First you solve the whole structure first, and then going bottom up, right? Yeah, okay, so that is question number 1. So it's quite short, right, as you can see, and this goes back to what I've mentioned in the introduction, right? So I mentioned that all these questions in the past exam have a certain context about them, right? So because we want to cram in many questions, so for each question sometimes we need the shorter question, right? So for trusses, only several steps you already complete. If you look at the book, there are questions that is much more longer, right? So for example, there's a bridge that's long, and then you have to calculate a free body diagram for five points, etc., right? So that is longer. That can happen, but as long as you understand the concept, it's just a repetition of free body diagram, equation of equilibrium, free body diagram, equation of equilibrium, right? Another thing, based on that as well, if you make a mistake up front, it will affect, right? So do check, do not make any mistake, because in trusses, or even in frame animation later on, it will be continuation like that, right? One mistake in front, it will affect the rest. Okay, moving on to question number 2. Okay, here is question number 2. We have the truss there on the right, and then the question says, determine the force in each of the member shown in the truss shown. State whether the member are in tension or compression. Use the method of joints. All right. So there's not many members here. 1, 2, 3, 4. Right. So it should be quite a short calculation, basically. Right. All right. So we need to find force in each member. Hence, we have 4 answers to give, right? Because we have member AB, member BD, member BC, and member CD. Right. So where to start? Right, so we find a point where we can straight away solve, right? So in this case, if you go to point B, you cannot solve, but if you can go to point C, you can solve straight away, right? So free body diagram at point C. So if you draw that, so basically you have 2 unknown force here, which is FCD and FBC, right? And then you have the force there of 600 kilonewton with the angle of 60 degrees. All right, so based on this, well, basically you can straight away calculate, right? So summation of fx equal to 0. Then you have minus fbc minus 600 cos 60 degrees equal to 0. Then fbc will be negative something, right? Negative. What is the answer there? 300 kilonewton. So this means compression, because negative, because we assume positive to be tension, right? All right, so we do summation of Fy equal to 0. Then you have minus FCD minus 600 sine 60 degrees equal to 0, right? So FCD, again a negative answer here. Negative what? 519.6. 519.6 kilonewton, meaning compression, right? So of course every of this is an answer, because the question asks for every single member, right? So we have negative 519.6 kilonewton compression, right? So having solved this, we can go to point B, right? So free body diagram at point B. So here we have external force, which is 800 kilonewton. And then for FBC, right? FBC, we know it is compression. FBC, we know compression, right? So it will be going inside. The value is 300 kilonewton. And then we have the two unknown, FAB and FBD. And what is the angle there? So it is 345, right? So it's straightaway ratio of 3, 4, 5. A reminder, a free body diagram have to include the angle, right? So if your angle is missing, you will miss some marks from the free body diagram, right? Because it's not complete. From here, you can solve summation of fx equal to 0, right? So we have fbd 3/5 minus 300 equal to 0, right? Meaning that fbd will equal to 500 kilonewton, meaning tension, right? Is it correct? 500 kilonewton tension, yes. Okay, so is the camera become blurry or something? Hopefully not. Okay, summation of fy equal to 0. So we'll have minus fab minus 800. Then this one, right? So in this case minus, so it's 500, and then 4/5 equal to 0. Minus, right? So FAB equal to, it will be a negative value, right? So this one becomes 400 and then 800. So 1200, is it? 1200 kilonewton, meaning compression, because it is negative, right? Negative 1200 kilonewton compression, right? So you have already completed the question actually, right? So this question is very short. Normally, because I take out the question to be just for the, how to say, for the same topic, right, in the tutorial. But if you look at the any particular exam question in totality, so you can see question like this. Normally it is a smaller part, part A, part B, part C. So for example, part A is this one, part B for frame, etc., right? So it is comprising of a lot of shorter question, but a lot of little question, right? So sometimes final exam can be like that, right? All right, so I think everything is understood. Moving on to question number 3. Okay, taking a look at question number 3. So we have the trusses on the right, and the question states, determine the force in each member of the truss in the figure and state if the member are in tension or compression. Take P1 equal to 2 kilonewton and P2 equal to 5 kilonewton. Draw the free body diagrams necessary. All right. So again, we have a truss. Obviously, we are covering truss, so we have truss. Right. So straight go into it, right? I think as we mentioned in the first question is always identify zero force member, if any, right? So here, if you can just see, there's none, right? There's no zero force members. Hence, we go straight into solving. So the point that we can solve straight away is point C, right? Because we have only two unknown there. So we can straight away go free body diagram at point C. Alright, so P1 is it P1? P2. Going down P2. So 5 kilonewton, right? So 5 kilonewton there. As the question states, P2 is 5 kilonewton. And then you have the two forces, the two unknown forces there, right? So here and here. So we have FCD, sorry, and FBC. And the angle, what is the angle? It is 30 degrees. So this end is 30 degrees. Right? So based on this, you can do summation of Fy equal to 0. So you'll have FBC sine 30 degrees minus 5 equal to 0. So So FBC you can calculate to get something, right? So based on the calculation, you get 10 kilonewton, and that means it is in tension. So what it is, the question says determine the force in each member, in every member. So this is one of the answer, obviously, right? So next, summation of Fx equal to 0. So you have minus FCD minus, based on the free body diagram, minus, but FBC is okay plus, so then minus 10 cos 30 degrees equal to 0, right? So FCD will be a negative value then, and the answer is 8.66 kilonewton. 8.66 kilonewton. So this is compression because we get negative, and we assume positive as tension, right? So we have solved for 2. So we have another 4 left. Next, we go to point D, right? So free body diagram at point D. So this one is straightforward. So we have, okay, P1 downwards is 2 kilonewton. And then we have FCD. FCD is this one, right? So FCD is compression. So it will be going in 8.66 kilonewton. And then we have the unknown, right? So let's say FDE here, and FBD here. Right? So if you do summation of Fy equal to 0, then FBD minus 2 equal to 0, FBD equal to 2 kilonewton tension. Right? And then if you do summation of Fx equal to 0, you have minus FDE minus 8.66 equal to 0. So FDE equal to minus 8.66 kilonewton, meaning compression. Next, we can go to free body diagram for point B. Do you have enough space here? Okay, I'll do it here, alright? So free body diagram of point B, right? Okay, so right, so FBC is tension. FBC is tension. So tension 10 kilonewton. And then FBD is tension as well. So 2 kilonewton. And then we have 2 unknown here, right? So here unknown and here unknown. So FAB and FBE, right? And the angles are 30 degrees, 30 degrees, right? So all of these are 30 degrees, 30 degrees, 30 degrees, correct? Okay, right? So from this you can solve. Does it involve simultaneous equation? It does, right? All right, so summation of Fx equal to 0. Basically, you'll have, okay, minus FAB cos 30 degrees minus FBE cos 30 degrees, and then plus 10 cos 30 degrees equal to 0, right? So that's the equation for Fx. If you do summation of Fy equal to 0, then you have FAB sine 30 degrees minus FBE sine 30 degrees minus 10 sine 30 degrees, and then minus 2 equal to 0, right? Okay, so if you do this, the rest is mathematically solved, right, using simultaneous equation. Right, so I have done it on paper, but I don't intend to just do the whole thing here. I think you know what to do. But if the calculation is correct, then you will get FBE is minus 2 kilonewton, meaning compression. F A B equal to 12 kilonewton, which is tension. So FBE negative 2, FAB 12. Alright, so you have solved for all the 6. 1, 2, 3, 4, 5, 6. Right, so yeah, that's how you solve it, one step at a time. Right, so the step is always the same for trusses. Right, free body diagram, Fx, Fy, free body diagram, Fx, Fy, free body diagram, Fx, Fy. Right, so in some question, okay, so far in all of the question that we have solved, everything you can solve straight away, right? But I think there's one question afterwards. After this, towards the end, there will be question where you have to solve support reaction first in order to solve, right? So we will take a look at that, right? So that question also exists. Anyway, going to question number 4. Okay, this is question number 4. We have the truss there, and then question A. Determine the force in each member of the truss in the figure and state if the member are in tension or compression. Set theta is equal to 30 degrees. Draw all the necessary free body diagrams. Okay, so for the question, you can see the theta on the bottom right there. So the theta is given as 30 degrees. And then part B, what will happen if the roller at C is replaced by a pin joint and Y, right? So there's a understanding question as well there. All right. So I mentioned in the previous question, right, that at the end of the previous question, right, so we have covered the question so far is all that you do not need to solve for support action, right? You can straight away solve for members, each members straight away. But this question you cannot, right? So because if you see at part, for example, if I want to start at D you have 3 unknown, right? At B you have also 3 unknown, right? So you actually have to solve support reaction first before you are able to solve for each member, right? So in this question, you have to solve using the previous chapter first, right? Using the whole structure and calculating for support reaction, right? So free body diagram of the whole truss, right? So we have the triangular shape there with something like this, right? So the external force first. So we have here 4 kilonewton, and then we have here going down 3 kilonewton, and then we have pin support at A, so AX and AY. Roller support at C, so we have to draw a perpendicular force to the surface, right? Normal reaction, right? So we have something like here of NC, right? So the degree here is 30 degrees as given, right? Okay, and then we have 2 meter, 2 meter, and 2 meter there, right? Okay, so that is basically the free body diagram of the whole truss. So from here you can solve for AX, AY, and C, right? For example, if I solve for summation of moment about point A equal to 0 first, if I take counterclockwise as positive, so taking moment of this, so NC, the vertical part is NC cos 30 degrees, right, times the distance of 4. The horizontal part doesn't produce any moment because it goes through the point A. So this was positive counterclockwise, so and then 4 kilonewton is clockwise, so minus 4 times 2, and then minus 3 times 2 equal to 0. Okay, is the camera become blurry because I didn't see. I hope it's not, but if it is, I'm not sure what it is, right? Okay, Bismillah, hopefully. Okay, so hopefully you're still able to follow until this point. I really sincerely hope. But I think you understand what we are doing, right? Some free body diagram and then summation of moment equal to 0 here, right? So from there you can solve for NC, right? So based on the calculation that I've made, so this is 4.04 kilonewton, right? 4.04 kilonewton. Obviously it will be positive because normal reaction the direction is not assumption, we know. So based on this, we can do summation of fx equal to 0. So based on this whole thing, ax plus 4 minus nc, which is 4.04 sine 30 degrees to 0. So based on this, ax equal to something, what is it? Minus 1.98. Minus 1.98. This is kilonewton. So what does this minus mean? It means it is actually to the left, right? Because we assume to the right, so it's actually to the left. And then we do summation of fy equal to 0. So we have ay and then minus 3 for this one, and then plus nc is 4.04 times cos 30 degrees equal to 0. So from here, ay you will get, what is it? Again negative 0.50, negative 0.50 kilonewton. What does negative mean? Meaning it's actually downwards, right? All of this direction have a direct implication to the next part, because we have to know the direction, right? So based on this, we can begin with solving truss using method of joints, right? So depend which point you want to start with. You can start with right now point A, because you have two unknown there, or part C, you have two unknown as well, right? So let's start part A, for example, not part A, point A. So free body diagram of point A. So if I'm to draw, so ax, ay, so ax is to the left, so 1.98 kilonewton, and then ay is downwards, 0.50 kilonewton, and then you have the two unknowns, so fab and then fad. So what is the angle? So either you want to use 1 square root of 2, or you want to use 45 degrees. It should be the same, right? 1 square root of 2 ratio, or 45 degrees, right? So based on that, you can solve. So let's solve for summation of fy equal to 0, for example. So you have fad. If I'm using the ratio, so it's 1 over square root of 2, and then minus 0.50 equal to 0. So from here, fad you can know, and to get a positive value, which is 0.707 kilonewton, meaning tension, right? So based on this, if you do summation of fx equal to 0, then you'll have fab plus this is tension, then plus 0.707 1 over square root of 2, and then minus 1.98 equal to 0, right? So here, from here you can get fab equal to 1.48 kilonewton, meaning tension. So we have, okay, this is one of the answer as well. So we have solved for 2, right? So we have 5 members, right? So moving on. So this one is at A, right? So where can we go on? We can go on to part B, right? Yeah, we can go to part B. So if I go and solve for summation of, okay, free body diagram at part B, at point B, right? So there's 3 kilonewton there, and then we know FAB is 1.48 tension, so 1.48 kilonewton tension there, and then 2 unknown, right? So BD and FBC. So from here you can do summation of fx equal to 0, for example, then you know FBC minus 1.48 equal to 0, FBC equal to 1.48 kilonewton tension. And then you can do summation of Fy equal to 0, FBD minus 3 equal to 0, FBD equal to 3 kilonewton, another tension. Alright, so we have solved for 1, 2, 3, 4. So we have one more to go, right? So you can go either point D. Okay, hopefully I can put the diagram somewhere. You can still go for point D where you have only one unknown, which is FCD, or also you can go to point C, right, and then solve for FCD, right? So either way should give you the same answer, right? So what space I should use that one? Okay, so I'm using point C for example. So free body diagram at point C. So at point C you'll have normal reaction just now is, what is it? This one, 4.04, right? 4.04 kilonewton with angle of 30 degrees, right? And then you have FBC, which is known already, right? So 1.48 tension. So that direction 1.48 kilonewton tension. And then you have FCD upwards there, FCD with the angle of, it's still 45 degrees or 1 square root of 2, right? So based on this, you can do summation of Fy equal to 0, then you'll have FCD 1 over square root of 2 plus 4.04 cos 30 degrees should be equal to 0. Then you can calculate FCD equal to negative 4.95 kilonewton, meaning compression. 4.95, right? Of course your answer is complete. 1, 2, 3, 4, 5, right? So but you can still, and if you do have the time, it is advised that you actually solve for summation of Fy, right? Summation, if you do summation of summation of Fx equal to 0, right? If you do this, you'll have, for example, minus 1.48, then minus 4.04 sine 30 degrees, and then minus, then you have that minus there, so negative 4.95, and then 1 over square root of 2, right? Verify whether this is correct, right? So because if you do this, this and this, you should get 0, because that's the equation. If you get this, this and this, you get something else, something else equal to 0, something is wrong, because 4, 3, whatever number cannot be equal to 0. Normally here, because we have round off error from previously, you might get 0.0 something something, perhaps, right? Because this is round off, right? So that is the issue of error that we embedded when we round off in the calculation, right? But if it's close enough to 0, then inshallah it indicates that everything is correct. But if you get a number equal to 0, something is wrong. That is not possible. A number 4 point something, 3 point something equal to 0, right? So I noticed that also. This is already finished on this, but as I mentioned about that, I did notice as well some student in the exam, when they do free body diagram and then they write the equation of equilibrium, it's obvious that all of here is number, and if you add up it becomes something number, a big number, and then suddenly equal to 0. You should be able to notice that something is wrong there. You should not just leave it there. Oh, okay, 500 equal to 0, that seems nice. So, meaning you are trained to be an engineer. You're not just blindly calculating, right? So make sure you can understand something is wrong if you see something like that. Alright, so with that said, I think it is clear how to solve this, and this is one question that actually you are forced to calculate for support reaction first before you can calculate all of this, right? Alright, so moving on to question number 5. Okay, before we go to the question number 5, I think I have forgotten about part B of this question when we do the recording. What will happen if the roller at C is replaced by a pin joint? Why? Alright, so if you have done the part A calculation, it should be clear that we need to solve first support reaction first, and then for solving support reaction, we have 3 equations: summation of fx, summation of fy, and summation of moment equal to 0. So if point C is no longer a roller but becomes a pin, now we will have 4 support reaction, right? Ax, Ay, Cx, Cy. So in that circumstances, in that situation, we cannot actually solve this problem because we have more unknown than number of equation that we have to solve for support reaction. And in this particular question, if you do not able to solve for support reaction, you cannot actually calculate the force in each member. Yeah, so that is basically the concept related to this question part B. Hopefully you can express in your own words to show that you actually understand what is the effect when you change that support. Alright, okay, this is question number 5. We have the truss, and the question says, consider the truss in the figure, determine the forces in member CD, DE and CE, state whether the said members are in tension or compression, right? So we need to find FCD, FDE and FCE. Right. Is the marker still okay? Should I try another color? Alright, so based on this question, so let us see where is this force is, right? So FCD, oh, it's at the top there. FDE is also on the top there. FCE is in the middle. So in actually in this question, you need to only calculate that 3 forces, right, for the 3 member on top. So you don't need to even calculate on the bottom there, right? So in this semester, I think either they really need a very, very short question, so they throw this in, or the lecturer is becoming super nice in that semester and okay, let's just give the student free marks. Practically free marks. You have to work for it, but it's practically free because that's so simple. Alright, so I think you understand the question, and I think you understand what you need to do. There's no zero force member there as well. So straight away to free body diagram at point D. Can you see the color blue? Alright. So if you draw the free body diagram there, so you have the 300 Newton to the left, the external force, and then you have the 2 unknown, FCD and FDE, right? And then the angle is, what is that? 6, 8, 10, right? 6, 8, 10, or 3, 4, 5. Basically the ratio 3, 4, 5, right? Okay, this blue color, is it? Hopefully it's clear. Okay, hopefully it's clear. Okay, so based on this, it's just summation of forces, right? Summation of Fx equal to 0. Then you'll have minus FDE 3/5, and then minus 300 equal to 0, right? So FDE is negative something, right? Negative 300 divided by 3 is 100, 500, right? So minus 500 Newton, meaning this is compression. And then you can do summation of Fy equal to 0. Okay, this FDE is already solved, this one, right? Now, so what is it? I'm solving for Fy, right? So minus FCD minus FDE, but FDE is negative, so negative 500 inside. So 4/5. This should be equal to 0. Now, so FCD, so this become positive. Okay, so it become positive answer, right? So here 400 Newton, meaning tension. Right? So you already solved for FDE and FCD. So you need one more, which is FCE. Right? So FCE you can straight away see. Then I can focus at point C. So free body diagram at point C, and then straight away solve what you need. Right? So because the free body diagram is just 500 external force here, 500 Newton, and then FCD is 400 tension, right? So upwards 400 Newton. Then you have the two unknown, FCE and FBC, right? But what you need is just FCE, right? Because the question only asks for 1, 2 and 3. So if you do summation of Fx equal to 0, then minus FCE minus 500 equal to 0. FCE equal to negative 500 Newton, meaning compression. Right. So you already solved FCD, FDE, FCE, right? And then your job is done for this question, right? So yeah, meaning that if that's the only thing that the question wants, there's no need to proceed and calculate for FAE, FBE, etc. Right? So there's no need. Yeah. So that is the final question of the day. So I hope you can see that it's not difficult to solve a question for trusses, but you have to know the fundamental and the basics, right? So what to do, free body diagram and equation of equilibrium, right? So that's the repetition of the step, free body diagram and equation of equilibrium. However, in a certain question, there are zero force member. You have to be able to identify those, because if you identify and do not identify, the level of difficulty will be different, right? So number one. Number two, in some question, as we have covered in question number 4 today, I think you might need to solve for the support reaction first before you can go to method of joint, right? So that's two things, right? So other than that, I think it's quite straightforward, right? It's quite straightforward. But important note, because it can be a chain of free body diagram equation, free body diagram equation, free body diagram equation. If you make a mistake in the first free body diagram, then the mistake will affect the whole chain of calculation, right? So that's the very important thing that you have to ensure. Check, ensure no mistake, especially when you deal with negative value, right? So for example, you calculate, you get negative, and then how to proceed with the next free body diagram. Make sure you understand that really, and also make sure you understand what you are doing with tension or compression, right? So if you mix that up, because normally in the answer here, for example, depend on the examiner and answer scheme as well, but for me, normally this is half of the mark and half of the mark, right? For example, this 2 marks here, for example, then one mark for the value, 1 mark for the statement of the tension or compression. So do not miss that statement, whether it's tension or compression, and make sure you understand why is it tension, why is it compression. I think that's all for today, inshallah, alhamdulillah. So we have finished with trusses. Next tutorial will go into frames and machine, right? Thank you. Do like the video if it has been helpful. Inshallah, that will help the video actually in terms of the YouTube algorithm. Wallahu alam, subhanakallahumma bihamdik, ashhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. See you next time. Assalamualaikum warahmatullahi wabarakatuh.